Hello, let's continue our Sudoku adventure with Little Serial Killers by SennyK. So we have normal 6x6 Sudoku rules. That means in each row, each column, and each 2x3 box, we are placing the digits 1 to 6, exactly once each. We also have these lines in the grid. These are same difference lines. Every pair of adjacent digits in the line, so these two and these two, have the same difference. Different lines can have different differences, but within the same line, they have to have the same difference. So if this was 2, 4, that's a difference of 2. This could be 2, again, that has a difference of 2, or it could be 6, because those have a difference of 2. What I can't do is like a 5 here, because that's difference 1, difference 2. Those don't match. All right. And finally, we have these clues outside the grid. There is an arrow pointing diagonally. Just follow all the cells in that direction until you hit the edge of the grid, and all of those cells will sum to the clue given. So these three sum to 12. And that's it. Those are the rules. There's a link in the description if you'd like to try the puzzle yourself. And I'm going to get started right now. All right, there's a few things I know about 3-cell lines that should be helpful in this puzzle. Firstly, we know that, I guess the most important thing is that we know that these two outer cells have the same parity as each other. They're either both even or both odd. Because whatever goes in the middle, we're doing the same difference to here and the same difference to here. And so they're either the same digit entirely, or at the very least, they're the same parity. So these are either both even or both odd. But no matter what, because they're both even or both odd, they will add to an even number. 2 evens isn't even, 2 odds isn't even. And so that means that this is an even number as well in order to preserve evenness to add to 12. So if this was a 2, these would need to add to 10, so they'd both be 5s. If this was a 4, then these need to add to 8, which would be 2 6. We do 2 4 6. And if this was a 6, these both add to 6, which would be double 3. All right. Because with 6 in the middle, we're not doing 2 4 6. All right. I don't know if that's super helpful at the moment, but we can look at the rest of these. So this is the same. This is 2 4 6 with 2 3 5 6 on the edge. Because, oh no, sorry, this has to 11, not 12. Ooh, I misread that. So add to 11, these are both even. This has to be odd, 1 3 or 5. And with a 1, these two add to 10, so it would have to be double 5. With a 3, these two add to 8, so it would be double 4. Yeah, with the 3 in the middle, I think double 4 is the only option. We can't do 3 5 or 2 6. That doesn't make any sense. With the 5 here, these two would add to 6, and that would be double 3 then. So are these always the same digit as each other? With the 5, yeah, we're not doing 4 5 6. That's not 11. All right. So these two are the same digit. I'm going to use green to represent that they're the same digit as each other. Now here, these add to 12 again. So this is 2 4 6, and these are 2 3 5 6. Okay. So I guess we should look at this long line then. So the absolute minimum this could add to is a 1 2 pair here. Let me get rid of this for a second. Be a 1 2 pair here, 2 1s here, and a 1 2. We're ignoring the sequence line. We're just doing the little killer. But of course, because it's a sequence line, these can't be the same digit as each other. That would be 1s all the way down. And so actually this is a 1 2 pair as well, minimum. That adds to 9. So we have 2 degrees of freedom. But we clearly have a difference of 1. If we had a difference of 2, with 6 cells, difference of 2 preserves parity the whole time. It would always be even. Difference of 3 would just be way too big, I'm pretty sure. Yeah, I mean, there's no way it's difference of 3, right? Difference of 3 would be like 1 and then 4 and then 1 4 1 4. We'd have 3 1s and 3 4s, which is way too big. The 4s on their own are 12. Okay, so I think what we'd have to do is 2 1 2 pairs and then a single 2 3 pair, which would be 5. So these are from 1 2 3. If I tried to do 1 2 3 4, that already adds to 10, and I'd have to go back down to 3, which would be already 13. Yeah. Okay. So one of these is a 2 3 pair, and then the other's a 1 2 pair. So they always contain 2s. And in fact, the 2s are going to be every other, either here or here. Because of the parity swapping with the difference 1. I mean, I can say since there's a 2 in one of these two, because it's either 1, 2, or 2, 3, right? There's a 2 in one of these two. These can't be 2. So that means 2's here and here. But that means that's not a 2 and that's not a 2. I don't know how that updates this one. I don't know if I want to think about that right now. Is there more to this that I can do? Because I've looked at every clue now. There's a 2 in one of these. Okay. So 11. See, if this was 2, I'm trying to figure out which one's 2. If this, and this has a crossing clue. So if this was 2, then these would need to be double 5. 3, 4, 5. Huh. Do I have any more going for this? 2. Wait, no, this adds to 11. Sorry. Did I do this right? Adding to 11? Wait a minute. I think I still made this add to 12, even after saying that it had to add to 11. Oh no, this wasn't 1, 2, 3, though. This was definitely not 1, 2, 3. Okay, this can't be even. This has to be odd. I think we already determined that, and I erased it when I did this diagonal. Sorry, that's my bad. So it can't be odd because, sorry, it can't be even. It must be odd. If it was even, then we would add to an even sum, and this is 11. So this isn't the 2. That does mean this is 2, 2, and 2. And these are the 1, 3s. Okay, that's helpful. And that places this 2. These are not 2s. Okay, we're going to update this in a second, but let's place all our 2s, I think. That's a 2. And that's a 2. We're done with 2s. Okay. So this is 4 or 6 now, and this is 1 or 3 now. I guess I can update all of these. We know these are always the same. So with the 1, they're double 5, and with the 3, they're double 3. No. Sorry, 1 is double 5, 3 is double 4. These aren't... 2 was never going to work, right? It was 5 that was double 3, yeah. So these are 4 or 5, and they go down here. And so this has to be 4. We have to reconcile the 4, 5 with the 4, 6. Because these are the same digit. And so this has to be 4, and this is 4, and this is 4. Okay, now that we know this is double 4, that's 8. This has to be 3. This is 4. So to get to 12, we to be double 6, right? It's the only way these two can add to 12 is double 6. Sorry, we're trying to get to 12. Sorry. We already have 4. These need to add to 8. We can't do double 4, so it's a 3, 5. Okay, that's... Sorry. I don't know why I'm making these mistakes. This is 4 or 6. So it's no longer 2. 2 was the double 5. So this is now... Interesting. Do these always contain a 3? Is that true? Yeah, double 6 would already be 12. So these always contain a 3. And they see this one, so that makes that 1. Oh, we already have a 3 here, so that's 1 as well. I could have done that earlier. I think I got to... I was doing a lot at once. So what's kind of our next step? This 4 ends up here. This is a 1. That's a 6 now. 6 has to go with double 3 to add to 6. All right. And this 4. This is a 3, 5 pair. I should remember that. So what's left here? This is 1, 2, 3, 4. Well, this is 5, 6. So this is 5. This is 6. And this is 3, 5, 6. That's not a 3, but this also isn't a 3 because one of these has to be 3. It's a 3, 5 pair, actually. So this can't be 3 or 5. So that's 6 and that's 5. That gives us 3 here, and that's 5 now. All right, I think it's just Sudoku from here. This column finishes with a 6. This is a 1, 5. This 5 tells us that's 1, that's 5. Over here, we need the 4, and then up here we need 1 and 5. This is 5 and 1. That 1 down there. Column finishes with a 6. This column finishes with a 3. These two digits, we need this 5 here. We need the 4 there. This is 3 and 1. This is 6. And we're done. All right, cool puzzle, Senny. I liked the use of knowing the sum of the line, but also knowing that these two had the same parity and were often the same digit. That was neat. And then this one where because it alternated by one, we knew that all of these had to be two. That was neat. All right, well, how'd you do?